What do this rattlesnake, this dragster, and you all have in common? One thing they share, they all need a source of energy to function. But another thing that the snake, the car, and you have in common is symmetry. If you took an imaginary plane and placed it through the top of your head, all the way down through the bottom of your chin, you'd notice that the portions of your face on both sides of the plane are nearly identical. One eye and half of your nose, mouth, and chin. These two portions of your face are mirror images of one another, reflections. When a form has equal mirror images on both sides of a line or a plane, the form has bilateral symmetry. The plane that divides your face in two is a plane of symmetry. If you look at both the rattler and the car, you can see that the same principle applies. Using a plane of symmetry, we can bisect both into two essentially equal pieces. They look nearly identical, but are reflections of one another. Here's another type of symmetry. If we rotate the pentagon 72 degrees on its center point, the shape looks identical. This type of symmetry is rotational symmetry, because the shape is the same after rotating around a center point. In general, an object has symmetry if transformation results in the object looking the same. Rotation of a shape is one type of transformation. A transformation is an operation that moves or manipulates a shape. Another type of transformation is translation. In translation, every point of a shape moves the same distance, in the same direction. You can see a translation in the movement of this helicopter over the Rocky Mountains. When the helicopter flies to a new position while keeping the same orientation, its physical motion is a translation. Let's take a closer look at some shapes and see how various transformations affect them. Los Angeles, the movie capital of the world, attracts millions of tourists each year. One of the city's most famous attractions can be found right under your feet, the famous Hollywood Walk of Fame. Here's the star for Johnny Depp. If we draw a line down the middle, we can see that the star looks symmetrical. We can use the XY coordinate plane to confirm this. On this plane, every unit equals 1 inch. First, let's place the star on the plane so that the line we drew down the middle lines up on the y-axis. Now we can see that the points on the star to the left and the right of the y-axis have corresponding coordinates with opposite values for x. For example, the point 1720 has a counterpart with the coordinates -17, 20. Now let's try it another way. Put the star's center line along the line y equals x. The shape's center line is now oriented diagonally. Notice that the points on opposite sides of the line have their xy coordinates exchanged. The point 9.53, 33.56 is opposite the point 33.56, 9.53. We can also fold or flip the image over the line y equals x. Notice that after the image is folded, the points that were located at 9.53, 33.56, and 0, 14.85 are now directly on top of their corresponding points. This proves the shape has line symmetry. And this folding test will work with any object with line symmetry. London is one of the world's oldest cities. Its origins can be traced back to the year 43 AD when the Romans conquered Britain. One of the first things the Romans built after their arrival was a wooden bridge spanning the Thames River. This bridge was located not far from the site of the current London Bridge, one of the city's most famous landmarks. The earlier version built by the Romans attracted settlers to the area. A town eventually developed, and over time this small town transformed into one of the world's most famous cities. We can also consider geometric transformations, but they're of a different kind. When you manipulate an object or shape using mathematical operations, you transform it. One type of transformation is rotation. a rotation can be used to detect rotational symmetry. If an object can be rotated less than 360 degrees around its center point, and the result looks identical to the object in its original position, then the object has rotational symmetry. The London Eye is now one of the city's most recognizable landmarks. At over 450 feet tall, the wheel provides breathtaking views of the city. You can tell the London Eye has rotational symmetry because when it's rotated just a few degrees, it looks identical to the way it did in its original position. Another type of transformation is translation. An object undergoes translation when every point on the object moves the same distance in the same direction. When this research boat moves forward, without changing its orientation, it undergoes a translation. Suppose the boat travels 5 miles straight ahead to conduct more experiments. We can sketch a boat shape on the XY coordinate plane and translate it to its new position. We'll call the boat in its first position pentagon A, B, C, D, E. Each unit on the plane represents 1 foot in length. Now let's translate the figure forward 5 miles, or 26,400 feet, along the line y equals x. To translate the form of the boat along this line, we can use the Pythagorean theorem to determine the amount each coordinate must change. Since x and y change the same amount, we can figure that it's approximately 18,668 feet. Adding 18,668 to the x and y values of each point, the translated boat form will be located at these new coordinates. Remember, a translation is a transformation done by moving every point on an object the same distance in the same direction. Also, translations and rotations are types of transformations. In today's world, people often transform themselves. Some work to transform their outward appearance by exercising more. Or they transform their inner selves by meditating or by following the advice of self-help books. There are also several types of geometric transformations. One type is reflection. A reflection of an object is the set of points opposite the object's points. These points are located across a line or plane of reflection. Each point in the reflection is the same distance from the line or plane as the corresponding point of the object. The result is a mirror image of the original shape, with the line or plane acting as the mirror. Look at the flag on this beach. Let's plot its form on a coordinate plane and call it flag ABCD. The flag measures 4 feet by 6 feet. Each unit represents 1 foot. Now we'll reflect the flag across the y-axis and call the new flag QRST. The key here is that in the reflected flag, the values of the y-coordinates will be the same, but the values of the x-coordinates will be opposite. In other words, the reflection of point D at 3, 1 will be located at the coordinates -3, 1, point T. It will be the same for the rest of the flag's points. Remember that the reflected flag is a mirror image of the original, causing the colors and position of the diagonal line to flip. Now let's take our original flag and reflect it again. This time, we'll use the line y equals x as our line of reflection and call the new flag WXYZ. The technique when reflecting an object across this line is to switch the values of x and y. In other words, point A at coordinates 3, 5 will be reflected to the point W at coordinates 5, 3. Notice that W is located inside the first flag. We use the same technique to flip the rest of the points across the line of reflection. Remember, when reflecting an object across the y-axis, the x values in the reflection will be opposite those in the original. And when reflecting an object across the line y equals x, the values of x and y will switch.